Hello. In this video, we're going to graph the function by finding the following information. We want to find the end behavior, the zeros, their multiplicity at those zeros, and the behavior at those zeros. Then we're going to find the y-intercept and just kind of plot all of it together. Okay, so to graph the function, we first want to find the end behavior. And what that means is we really want to know what is the degree. And believe it or not, it's actually easiest to just kind of look at this in general form. So since f of x equals 2x cubed times x plus 1 squared times x minus 4 is in factored form, that's actually more difficult to find the end behavior. In fact, it's the most difficult part. So what we're going to do is we're going to say, notice that we have x cubed, here is x squared, and here is just x. So 3 plus 2 plus 1 is 6. And notice that there's a coefficient there of 2. So the leading power function here is going to be y equals 2x to the 6th power. And since we have x to the 6th, that is even, so we have two possibilities. They're both going to go up, or they're both going to go down on each side. And with the leading power function being positive, it's going up on both sides. So for the end behavior, to the left it's going up, and to the right it's going up as well. Excellent. Now to find the zeros. Finding the zeros is actually easy, and in fact we could just write those down if we wanted to here. But let's go ahead and see how you do that. We would set the function equal to 0. So 2x cubed times x plus 1 squared times x minus 4 will all equal 0. And then just set everything equal to 0. So 2x cubed equal to 0, x plus 1 squared equal to 0, and x minus 4 is equal to 0. Notice that for the first one I would divide by 2, which gives me x cubed equals 0, and so x equals 0. For the second one, a square root property means x plus 1 equals 0, technically plus or minus 0, but there is no such thing as a plus or minus. And then just subtract 1 from both sides, so x equals negative 1. And for the last one, of course, you get x equals 4. So the zeros are going to be negative 1, 0, and 4. But here's the thing, we didn't actually have to do any of this. We could have simply looked at the function and determined what the zeros are. Notice that anytime you have x to some power by itself, that's always going to be the 0, because x equaling 0 will give the entire function equal to 0. And then notice that 1 here, x plus 1 gives us negative 1, x minus 4 gives us positive 4. Excellent. As for their multiplicities, those come from the exponents. For the negative 1, its exponent was a 2. So the exponent, or the multiplicity, is going to be 2. For the 0, that came from this term here, and that exponent was 3. So the multiplicity will be 3. And for the 4, it came from this one, and it's an understood 1, so therefore the multiplicity is 1. By the way, when you add these together, 2 plus 3 is 5, plus 1 is 6. That had better be the same thing as the degree of your leading power function. As for the multiplicity, as for the behavior at the 0, if the multiplicity is even, it bounces, and if it's odd, it crosses. So with a multiplicity of 2, it bounces. With a multiplicity of 3, it crosses. And with a multiplicity of 1, it crosses. Excellent. Now for the y-intercept. Just set every x equal to 0 and solve. So you get 2 times 0 cubed times x plus 1 squared, 0 plus 1 squared times 0 minus 4. And then simplify. You'll get 0 out of that. So your y-intercept will be the coordinate 0, 0, and if my math lab asks, that's just the coordinate of, or it's just 0. Awesome. Now that we've done that, we can actually plot all this. The first thing I'm going to do is I'm going to plot the zeros. Zeros are negative 1, 0, and 4. Fantastic. Now that we've done that, notice that we can look at the end behavior. The end behavior means up to the left and up to the right. So beyond the last 0 here, to the left, that -1, the farthest one to the left, we're actually going to be going up, guaranteed. And the one beyond to the right, beyond that to the right, we're going to be going up as well. That's what the end behavior is telling us. Now, we have a y-intercept of 0, 0. We've already plotted that. And now let's look at the multiplicities and the behaviors. At that -1, it bounces. So, as we're approaching that x, we're going to bounce off to the other side. So it's going to look something like that. And it's going to come back down to the 0, and at the 0 it crosses in a cubic fashion. It's kind of weird to do that there. Let's do this. Bounces up, and then for the 0 it is cubic. And then notice that we crossed to the other side. Good. And then we're going to go back up towards this 0, and we're going to cross in a linear fashion. So crossing there, and then just kind of connect everything. Connect, 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 and connect. And this is just a rough sketch of what this graph is going to look like. It's not perfect by any means, and I don't expect it to be. But if you want to see a perfect graph, you can just type f of x into your calculator and see what it looks like. All right, I'm going to go ahead and end it there, and I will see you in the next video. Have fun.